Hello students, in the last class we were discussing about the Unit 5 LoRaWAN specifications, and in yesterday's class we were discussing about the difference between the LoRa and LoRaWAN. So LoRa is basically a physical layer and LoRaWAN is a network layer. So that we were discussing, and LoRaWAN architecture also we have discussed yesterday. So this is about the architecture. And then this is the network architecture. This is a LoRa network architecture, means it will be having the end nodes, the gateway, network server, and the application server. And we were discussing about the all the components of the LoRa network architecture. So that is the LoRa nodes, end nodes, LoRa gateway, network servers, application servers, and LoRa devices classes. So how they class A, class B, and class C are classified. So that also we were discussing yesterday. And this is about the classes. So three classes: class A, class B, and class C. Class A is classified as a baseline, and class B as a beacon, and class C as a continuous. Class A is basically class A is bidirectional end device, and whenever we ask for the results or whenever we ask for the data, then only those sensors will be sensing and it will be sending the data to the gateway, and from gateway to the network server. That kind of sensors we classify into class A, and always the class A devices consumes the least power compared to the class B and class C. Then coming to the class B, so whenever we ask for the data, so that time also it will be sending, and with the scheduled receive slot. So here with the scheduled receive slot, and means with the scheduled time also it will be sending us the data, whatever it has sensed, that data it will be sending. And then next class C. So class C means it is a continuous one. So if the sensors, so if it is sensing the data continuously, or if it is sensing the parameters continuously, those we classify into the class C. And yesterday we were discussing about the all the message formats of the class A. So already we have discussed about these things. And today we should discuss about the class B devices. Class B devices we call it as a beacon, and class B is in a rough manner, it is a, we can call it as a updated version of the class A or next version of the class A. So how means, so it will be doing all the works of class A, but it will be sensing, means additionally it will be sensing at the scheduled time. So that we call it as a class B. So introduction to class B means LoRaWAN class B layer, which is optimized for battery powered end devices. Battery powered end devices that may either mobile or mounted at fixed location. Means mobile or mounted at the fixed location means sensor can be, it can be mobile in nature, or the data which we are sensing, it may be mobile in nature, or it may be mounted at the fixed location. So that we call it as a class B layer, and end devices should implement class B operation when there is a requirement to open receive windows at fixed time intervals. Means if we want the data at the fixed time intervals, then only so we should implement the class B, otherwise we should go for the class A. That is the meaning of this phrase. And LoRaWAN class B option adds a synchronized reception window on the end device. Synchronized reception means, so synchronized means at the scheduled time. So means unsynchronized means it gives a meaning of unequalness. Synchronized means it gives the meaning of at the equal or the scheduled time. So that is the meaning of synchronized. One of the limitation of LoRaWAN class A is Aloha method means sending the data from the end device, and it doesn't allow for no reaction time when the customer application or the server wants the address the end device. Means allow method means what means, so whenever we send the two downlink messages, or whenever we send the two, so receive, whenever the two message gets received, then only it will be sending the one data. It will sense and it will send the data. That is the major disadvantage of the class A. So coming to the class B, as it will be sensing in the scheduled time, that kind of problems it will not be existing in the class B installation. So major problem of class A is, so that is sending the two downlink messages to get the one uplink message. Yesterday we were discussing, that is a major disadvantage of class A. That method we call it as the Aloha method. And class B is achieved by having a gateway sending a beacon. So that is already class B beacon I have mentioned. So that format we call it as a beacon. So sending a beacon on a regular basis to synchronize all the end devices in the network. Means regular basis means in the scheduled time to synchronize all the end devices in the network, so that the end device can open short additional reception window. So that will be called as the ping slot. So whenever we ping, it will be sending the data. So that is the meaning of ping slot. Ping slot will be available in the class B installation at predictable time during the periodic time slot. So that is the meaning of scheduled time. And then the next is, that is the principle of synchronous network initiated downlink. Means it is related to the class B. So we should discuss about what is the meaning of synchronous network initiated downlink. So meaning of the synchronous network initiated downlink is, so network to support the end devices of class B, all the gateways must synchronously broadcast a beacon providing a timing reference to the end device. Means all the gateways, so synchronously means there may be one gateway, two gateways, or number of gateways. All the gateways must synchronously broadcast a beacon providing a timing reference to the end device. That is the meaning of this. And based on the timing reference, the end devices can be periodically open receive windows. Open receive windows means that is just to receive the message. So whenever the uplink messages are to be sent. So that is the meaning of that. And it will be called as the ping slot. So already, so in the last we were discussing about that ping slot. So which can be used by the network infrastructure to initiate the downlink. So the title is only initiating the downlink. So downlink communication, a network initiated downlink using one of these ping slot is called as the ping. So if the network uses the ping slot to initiate the downlink, then it will be called as the ping. That is the meaning of that. And now, so before a device can operate in class B mode, following information must be made available to the network server out of band base. So these information must be available, so in order to make the class B devices to operate. That is, the device default ping slot periodicity should be known, so it should be available, and default ping slot data rate should be available, default ping slot channel should be available. So if these three are available, then we can operate in the class B mode. And so this is the procedure. So some 7 points are there, 7 to 8 points are there to convert the class A to the class B base. So initially it will be in the class A mode. To switch that into the class B mode, so there are certain procedures are there. So those are to be discussed now. So first procedure is, the end device application request the LoRa WAN layer to switch class B mode. So means first is requesting the LoRaWAN layer to switch to the class B mode, that is a first one. And LoRaWAN layer in the end device searches for the beacon and returns either a beacon locked, so service primitive to the application if the beacon was found, and locked, or a beacon not found service primitive. Means it will be so giving the, or it will be searching for the beacon first, so that LoRaWAN layer. So first is, so it can search the beacon and returns the beacon locked, or it will give the beacon not found. Means there are two options are available whenever it search for the beacon. So it can be found, so that time it gives the beacon locked, or if it is not found, it will give the beacon not found. And the second procedure is once the class B mode, means once the class B mode means, so in the first it is switching from the class A to class B. So once it is in the class B mode, MAC layer sets to 1. So the class B bit of the FCTRL feed, that is a functional reset feed, so it will set to the 1. So that is present in the MAC layer, so feed for every uplink frame transmitted. Whenever the uplink frame transmitted, so it will set the MAC layer to the 1. So that is the next procedure. And then the third procedure is a mobile end device must periodically inform the network server of its location to update the downlink route. This is a very important point. So you can go through this. A mobile end device means end device in so mobile mode must periodically inform the network server, means it should intimate to the network server. Network server, it will be there in the another side. So of its location, means where that end device is there, that location it should send to update the downlink route. Downlink route always it will be coming from network server to the end device. So we are knowing uplink means from end device to the network server side, and downlink means so from network server to end device side. So unless it is done, so it is not possible to switch into the class B. Means this is done by transmitting normal unconfirmed or confirmed uplinks. So whenever the uplinks are it is getting updated, so that time route of downlink also it will be getting updated when the devices are in mobile. So this is the third procedure. And the next procedure is at any time the network server may change the device ping slot downlink frequency or data rate by sending the ping slot channel request MAC command. So that is one command, that is a ping slot channel request MAC command. So network server it can change the device, that is a downlink frequency or data rate of the device at any time whenever it is switching to the class B. And the next is device may change periodicity of its ping slot at any time. Means periodicity of the ping slot also can be changed whenever it is switching from so class A to class B. To do so, it must temporarily stop class B operation. Means whenever it is doing that, so temporarily that class B operation should be stopped. So that is the meaning of that, and sends the ping slot info request. Means it will send the ping slot request that time. And the last procedure is if no beacon has been received for a given period, the synchronization of the network is lost. So class B means it is a synchronization. Means it is a synchronous one. So if the beacon is not found or if it is not received for a given period, and then so synchronization of the network will be lost, and that time MAC layer must inform the application layer that it is switched back to the class A. Means that time again it will be switching back from class A, class B to class A. That is the meaning of that. So here in the diagram it is clearly shown what is a beacon, what is a ping slot, where it will be, everything. So here network beacon transmission is there. Here end device RX window and here end device response is there. So whenever the network server, so that beacon transmission happens. So here the end device RX windows. So from here to here, this will be the beacon period, and then whenever the network beacon transmission, it sends the beacon signal, and then response will be going back. This is the end device response. It is going back, and then it gives a ping. So that we call it as a ping period. So always the ping period is shorter, and the beacon period is, so it is a bigger one. And then coming to the class C, already we have discussed about the class A and class B. Coming to class C, so if any of the sensors or if any applications are there continuously, it should sense the data. So that kind of sensors and that kind of applications, it will be classified into class C. So class C means it is a continuous one. So always, so in the third phrase you can go through. So class C end devices will listen with the RX2 windows. RX means that is a R means receiving, then RX means, so that is the receiving frequency 2. Then TX means that is a transmitting frequency. So now here we are discussing only about the RX. So always the class C devices, it will listen only to the RX2 windows. Means, so in this you can clearly understand that. So that is second receive window duration for class C. So here, so extends to next uplink. So that is for the next, and RX1 is there, RX2 is there, and here RX2 is there. So RX2 is responsible for transmission of data, means responsible for the, so next uplink are responsible for transmission of data from end device to the, so next means, so in the previous we were discussing, so always class C devices will listen to the RX2 windows, means it will not be responding to the RX1, and then so the end devices shall listen to RX2 when it is not either sending or receiving on RX1. Means, so whenever it is not sending or whenever it is not receiving on RX1, then only that end device shall listen to the RX2. Means, so that end devices is responding with the RX1, that time it cannot, so response, it cannot give the response to the RX2. That is the meaning of that. So this is about the class C installations. And then class C installation, so multicast downlinks are provided here. So here, so that is the procedure is given, that is the limitations of class C multicast downlink frames. Those the limitations are given, means they shall not carry MAC commands. So that is a major disadvantage. MAC commands it will not be carrying. So neither in the F-op field, frequency optimization field, nor in the payload on the port 0, because multicast downlink does not have the same authentication robustness as the unicast frame. That is a disadvantage of multicast. And the acknowledgement and address track request bits must be 0. The M-type fields must carry the value of unconfirmed data run. This is also a, another limitation. Then F-pending bit indicates there is more multicast data to be sent. So that is also another disadvantage. And MAC comments are given here with respect to, so class C device model end, ND. So that is used by the end device to indicate its current operating mode, class A or class B or class C. Then the, so device mode conf means used by network to acknowledge that device mode int command. So that is about the MAC commands of class C. And now, so this is a very important part of this unit. So now we are going to discuss about the network server and the application server. So till now we have discussed about the end devices, different classifications and all. And now we are discussing about the network servers. So network server means, so network server transmits the LoRaWAN MAC layer for the end device connected to network, and it center the star topology. Means network server always in the center place of the star topology, and it terminates the LoRaWAN MAC layer. So that is a main important point of this for the end devices. Means, so here first is a end device part will be there. This is the first layer, and then from here, so data will be reaching the gateway, and from the gateway it will be reaching the network server, and then the application server or the joint server will be there. That is the last point. So always this network server will be at the center point of the star topology, and LoRaWAN it will be existing here. So it will terminate the LoRaWAN means, so it will not directly interact with this part. So it will interact only with the gateway. That is the meaning of that. And generic features of network servers are end device address check. So always the network server, it will be doing the end device address check. So for the security purpose, that is a very important point. And the frame authentication and frame counter checks. So means frame means how many messages, whether it is going up or down, means frame ups or frame down. So that authentications and the counter checks means how many messages we have received, how many have lost. So that check can be done here in the network server. Acknowledgements will happen in the network server. Data rate will be indicated in the network server. That is the data rate adaptation. Then responding to all MAC layer requests coming from the end device. So means it will be responding to the end devices. So to all the MAC layers coming from the end devices, and forwarding the uplink applications payload to the appropriate application layer. Means application layer, so it is on the next stage of the network server. So if the application layer, whatever the data required to the application layer, so it will be sending from the network server. And then queuing of downlink payloads coming from any application server, so to any end device connected to the network. Means downlink informations or downlink commands always we give it from the network server. So that time, so downlink means it is for the actuators. That time from the network server to the gateway, and from the gateway end device. So actuators will be getting the input. That is the downlink. And forwarding the joint request and joint accept message between the end devices and joint servers will happen in the network server. So this is all the features of the network server. So this is what the network server will be doing. And then coming to this part, so some of the important notations and the definitions are there that we should be knowing. So SNS means that is a serving network server, serving network server. So that controls the MAC layer of the end device. And then is the home network server, that is a HNS, is the where device profile, service profile, routing profile and device EUI. EUI means extended unique identifier of the end devices are stored. Means in the home network server, so this device profile, then the service profile, routing profile and the device EUI, all these things will be stored. and HNS has a direct relation with the joint server. Joint server means that is the next part of the, so means that is the layer between the network server and the application server, joint server, that will be used for the joint procedure, and it is connected to the application server. And when the home network server and the service network servers are separated, they are in roaming agreement. Means, so those two will be in contact, but it will be in the roaming agreement, and uplink downlink packets are forwarded between the SNS and the HNS. And forwarding NS, so that will be indicated with the FNS, is the network server managing the radio gateways. So radio gateways managing will be done by the FNS. When the SNS and HNS, when the SNS and the FNS are separated, they are in the roaming agreement. Means it will be in the roaming agreement. So there may be one or more forwarding network server servicing in the end devices. So always there will be one or more FNS will be existing in the end devices, and uplink and downlink packets are forwarded between the FNS and SNS. Then next is the joint server. Joint server, that is the JS, manages the over the air end device activation process. Whenever it is a OTA mode, this joint server comes into the picture. There may several joint servers connected to the network server, and a joint server may connect to several network servers. Then coming to the application server. So application server means that is the last part of this entire LoRa structure, LoRa network. So application server, so what is the main use of application server means? Always the application server will be storing the data. So whatever we are going to sense, or whatever the data analytics to be done, or whatever the mathematical analysis to be done, everything it will be happening in the application server. Always the network server will not be having any capacity to store the data, but the application server can store the data. So that is what the application server, and always the application server will be connected from the network server. That is the meaning of that. And then coming to this, home network server routes the uplink towards the appropriate application server based on the device UI. Means how to connect the application server means through the network server. So based on the device UI, DEV means device UI, device extended unique identifier. In addition to the aforementioned network elements, LoRaWAN architecture defines the following network interfaces among these entities. Means between these entities there are many other interfaces are there, network interfaces. Those network interfaces are HNS, JS. HNS means home network server, then the joint server. So there will be an interface between this. Interface is used for supporting joint activation or the joint procedure between the JS and the NS, between the network server and the joint server. So it will be doing the activation process. And the VNS JS, so that is the network server and the joint server part. And here, so it is the interface between the roaming activation procedure. So if it is a roaming activation procedure, so then we can use this VNS JS. And EDNS, so EDNS is, this is another interface used for supporting LoRaWAN MAC layer signaling and payload delivery between the end device and the network server. And another interface is, that is the AS HNS, so that is supporting the delivery of application payload and also the associated metadata between the application server and the network server. Then the HNS, this is the interface used for supporting the roaming signaling and payload delivery between the HNS and SNS. And then another interface is SNS, FNS, and this interface is used for supporting the roaming signaling and payload delivery between the SNS and FNS. Then the last is ASJS. So this interface is used for delivering application session key from the joint server to the application server. And now coming to this, so this is the end device types and the states. So end device types means, so we can classify it into different activation methods. So there are mainly two types of LoRaWAN end devices are there. One is the activation by personalization and the activation by the over the air activation, that we call it as the VOTA. So one is VOTA, over the air activation, otherwise another is ABP, that is the activation by personalizing. And then so this we call it as the end device activation methods. So this is the very important part of the unit 5. So end device activation methods means, so it is used for the secure data flow. So if the entire IoT system or the LoRa IoT system is to be secure, we should use some proper end device activation methods. So then it becomes the more secure one compared to the other IoT platforms. So what I do is we can discuss about directly about the end device activation. So first is activation by personalization, that we call it as the ABP in short. So ABP means it will be having the end device, network server, application server and manufacturer. And data frame, it will be uploaded from end device to the network server, and frame payload and metadata, it will be uploaded from network server to the application server. And how to make this to upload means, so this is what happens in the ABP. ABP means activation by personalization. So first, network server, it can generate the device address and network session key, and then end device will be having these three things, that is the device address, application session key and network session key. So if the end device is having these three keys, means we will be generating from the network server only and we will be pasting in the end device, or we can create from our side also, and we will be sending this to the next layers. So now our end device is having these three things: device address, application session key, network session key. And then first we will be sending the network session key to the network server. So that message will be sent from the end device to the network server. And if the network session key is matching, so network session key here and the network session key here, so between the network server and the end device is matching, then the communication can happen between the end device and the network server. Means we can send the data or receive the data from the network server or to the network server. And then if the application session key is matching between the application server and the end devices, and then data can flow from end device to the application server. This is what the meaning of the ABP. So if the keys are mismatching, so if our network server is not knowing what is the network session key, then the communication, it cannot happen between the end device and the network server. And if the application server is not knowing the application session key, then it is not possible to do the communication between the end device and the application server. So this is the security purpose. So if the different layers are knowing the keys which are generated or which are pasted in the end device, then only communication can happen from the first layer to the last layer. So this is about the activation by personalizing. And then activation of VOTA end device. So that is the activation over the air activation, we call VOTA mode. So VOTA mode means, So here one more server comes into picture. Already we were discussing in the last network server and the application server. During that time we were discussing, that is a joint server comes into picture. So in the ABP mode, end device, network server, application server, manufacturer. In the VOTA mode, end device, network server, the joint server, application server, and the manufacturer. So here, so first joint request will be sent from end device to the network server and look up for the IP address, means it will check for the IP address of joint server also, and then if it is matching, then network server, so it transmits that joint request to the joint server, and if it is matching, so it will send back to the joint answer. So after that, communication can happen between the same device up to the joint server, and then so from the network server, joint accept. So here joint answer, so it will answer yes, that is the key, like that it will answer, and then network server will accept that request, joint request. So then communication can happen between the end device and the network server, and data pack can be transmitted. So that is the meaning of this. And then application session key is matching between the joint server and the application server. Then the data packets can be transferred from network server to the application server. So here, so it will be sending the messages, and then by cross checking those messages, so if it is matching, so if it is matching with the, so whatever the request sent, then only so this will be happening. So here one more diagram is there. So here in a very simple manner we can discuss this. End device will be having the device UI, application UI, and application key. So means device extended unique identifier, then the application extended unique identifier, and the application key it will be having. And then network server will be knowing the application key, and if the application key is matching between these two, then the communication can happen between the end device and the network server. Means first joint request will be sent from end device to the network server, and this is the message format, and then so end device authentication will happen. In the authentication it will check for the device address, then the application nonce and net ID, then the message will be sent back, joint acceptance message will be sent back. So if all this are matching, and then so if the application session key is matching between the application server and network server, so transfer of data between the network server and the application server is possible. And this is about the so different keys which should get matched between the different servers. And we have come to almost end of this 5th unit of LoRaWAN specifications. And then coming to this RSSI and SNR. So what is the RSSI means? That is the received signal strength indication. So received signal means whatever the signal we are going to receive. So at the network server, so from the end device, and from end device to the gateway to the network server. So that signal strength indication we call it as the received signal strength indication. So is the received signal power in milliwatts and is measured in decibel meter, dBm, decibel meter. So it is always it will be in the milliwatts and it measured in the so decibel meter, and this value can be used as the measurement of how well the receiver can hear a signal from the sender. Means from the sender whatever the signal it is receiving at the receiver side, so quality of that can be measured. So here, so that is basically a quality of signal we call. So here you can observe, So here RX radio is there, cable antenna is there. This is the path loss, and if the path loss, so it is there here, and the noises are there, then the RSSI means the signal strength will be low, and if it is without noise, so then it will be good. So in the next diagram we can identify that. So here it is mentioned here. So if the RSSI is closer to the 0, then the signal is strong, and if it is so away from 0, then it is a weak signal. So minimum RSSI is minus 120 dBm, and then if it is minus 30 means it is very near to 0, then the signal is strong. If it is away from 0, minus 120, then the signal is weak. Hence, make sure your RSSI must be between the typical RSSI values to get the better signal strength. Means to get the better results, better response, always we should take into consideration, that is the RSSI. And the SNR means that is a signal to noise ratio. It is the ratio between the received power signal and the noise floor power level. So that ratio we call it as the SNR, and the noise floor level is an area of all unwanted interfering signal sources which can corrupt the transmitted signal, and therefore retransmission will occur. Means noise floor means it is an unwanted interference, unwanted interfering signals, so which can corrupt the actual signal, that we call it as the noise floor. And the ratio of, that is the received power signal to this noise floor power level, so that we call it as the SNR. Always the SNR should be greater than 0 for the good signal. Always we accept the SNR greater than 0. So if it is lesser than 0, so means received signal operates below noise floor. That is the meaning of that. If it is greater than 0, then received signal operates above noise floor, and normally the noise floor is physical limit of sensitivity. So that is definitely, and however the LoRa works below the noise level. So means, so here the values are given. So typical range is minus 20 dB to plus 20 dB. So if it is within this value, then the signal will be good, and the value closer to 10 decibel means received signal is very less corrupted, and if it is in the negative minus 7.5 or minus 20, then the received means it is below the noise floor, means it is a more corrupted value. So make sure that your SNR is between the typical values to get more LoRa signal strength. Means if the LoRa signal strength is to be improved, means always we should be having the greater SNR. So if the SNR is greater than 0, then it will be so very useful to get more LoRa signal strength. That is the meaning of that. This is about the first part of the unit 5, and some few concepts are there. So those are in the self-learning unit, self-learning topics. So you just go through those, and on a overview, this is about the unit 5.